Today, we're solving problem 5 and problem 6 from the AMC 10A of 2021. Okay, this 6-digit number 20210A is prime for only one digit of A. What is A? Well, we can, first of all, rule out, these are all the answer choices. It's pretty obvious. These are just the odd digits because it can't be even, because if it was even, then it could be divisible by 2. We first noticed that there's one number that we can immediately cross off, that being 5. Any number that ends in 5 can be divisible by 5. This is divisible by 5. You can check that. Now, we have to analyze our other answer choices. We have to use some clever number multiplication facts, I guess. We have to see if they're a multiple of one number. So let's just start with the 11 rule. It's basically adding every number in between, and then for example, for this number, you have to add 2 to 0. 2 plus 2 plus 0 is 4. And then you have to add all the other numbers. 0 plus 1 plus A. Well, if the difference between these two numbers is 0, then that means it's divisible by 11. But remember, we want a digit of A where A is not prime. So we have to rule out the ones that are correct. When A is equal to, when A equals, when A equals 3, this becomes 4, and then they can easily cancel. So we can rule off 3 here. That leaves us with 1, 7, and 9. Now we can use the divisibility rule by 3 to check. All we have to do for the number 3 one is we have to add all the digits of this number. 2 plus 0 plus 2 plus 1 plus 0 plus A. This gives us 5 plus A. If this value of 5 plus A is divisible by 3, then that means this whole number is divisible by 3. We get a few values where 5 plus A is divisible by 3. The first one being A is equal to 4, which is 9. A is equal to 4. 5 plus 1 is equal to 6. That can be divisible by 3. And then the other one is 5 plus 7, which gives us 12. So 4, 1, and 7 are all the digits of A that, when added to 5, are divisible by 3. So we can cross out the values that remain on here, 1 and 7. Now you notice, 4 is not on here because 4 is an even number. We already talked about the case of the even numbers. If A is an even number, it can be divisible by 2. That leaves us with only one answer choice left, which is E or 9. We're now moving on to problem 6. Elmer the emu takes 44 equal strides to walk between consecutive telephone poles on a rural road. Oscar the ostrich can cover the same distance in 12 equal leaps. The telephone poles are evenly spaced, and the 41st pole along this road is exactly 1 mile, 5,280 feet from the first pole. How much longer in feet is Oscar's leap than Elmer's stride? So we have to also note that 1 mile equals 5,280 feet. Okay, so we have telephone poles. Then the 41st telephone pole. Okay, so 41st telephone pole. This distance is 1 mile or 5,280. Now, we have to calculate the distance of this gap in between each telephone pole. Let's call that x. Well, we know that this is the 41st one, and the 41st telephone pole's distance from the first telephone pole is 1 mile or 5,280 feet. Well, there's 41 poles here, but the number of gaps is 41 minus 1, or 40 gaps. 40 gaps. So there's 40 gaps, and there's, all in all, this is 5,280, like the length of the total of all the 40 gaps added together, 280. Therefore, to find the distance of each gap between the telephone poles, we have to divide the number of gaps by the total distance. These zeros cancel out. We get us to 132. So the gap in between two poles is now 132 as a constant. Okay, so it says they walked between consecutive telephone poles. Let's just use 132. Well, we have to. Elmer walks 132 feet in 44 strides. So 132 divided by 44 to get the length he got per stride. This gives us 3 feet. 3 feet per stride. And this is for Elmer. I'm just going to write E. Now for Oscar. We can do the same thing. 132 divided by the number of leaps he took, which is 12. This yields 11 feet per leap. Now, Oscar walked 11 feet per leap, and then Elmer walked 3 feet per stride. 11 minus 3 is how much faster he was, or 8. Well, how much more he ran was, this is 8 feet per leap. Well, not per leap, but 8 feet.